In this particular question, we've been asked to find the general solution given that g prime of x is equal to 1 divided by x plus the square root of x plus 2 subtract 1 divided by 3 root x. Well, I'm going to start by stating g prime of x in a slightly different form, where I'm using exponents. So I'm going to have 1 divided by x plus x to the 1/2 plus 2 subtract 1/3 x to the negative 1/2. You may be asking yourself, why didn't I change that first term, 1 divided by x, into an x to the negative 1? Well, let's do that. I'm going to do it down in the lower part of the screen. I'm going to do it in green marker because we're going to erase this afterwards. Well, if g prime of x is now equal to x to the negative 1, according to my rules for anti-differentiation, what I should be doing is taking that exponent, negative 1, and increasing it by 1, so it becomes an x to the 0. Then I would take that 0 and divide it into my old coefficient, which was 1, so that my new coefficient would be 1 divided by 0. Wait a second, that doesn't make sense. 1 divided by 0 is undefined. Have I missed something by doing this? Well, let's take g prime of x and leave it as 1 divided by x and ask ourselves this. What function has for its derivative 1 divided by x? Hopefully you'll remember that it's the natural log of x. So by leaving g prime of x as 1 divided by x, I was hoping to prompt you that its antiderivative would be the natural log of x. So erase what we've done in green, and we'll now state g of x. G of x is going to equal the natural log of x plus, now my next term, I'm going to be taking my exponent, which was a 1/2, and I'm going to be increasing it by 1, so it becomes a 3/2. Then I take that 3/2 and divide it into my old coefficient, which was 1, and 1 divided by 3/2 is the same as 1 multiplied by 2/3. So my new coefficient is 2/3. So I have 2/3 x to the 3/2. I add to that 2x. That's what I get when I take the antiderivative of 2. And I subtract from that, well, my old exponent for x was a negative 1/2. I increase that by 1. So that means my new exponent is a positive 1/2. Then I take that 1/2 and I divide it into my old coefficient, which is 1/3. 1/3 divided by 1/2 is the same as 1/3 multiplied by 2/3. So I end up with negative 2/3 x to the 1/2. And then I add c, being my constant, and I say that c is an element of real numbers. In the next example, we're again asked to find the general solution, given that y prime is equal to 4 sine x plus 12 times the 4th root of x cubed. I start by restating that derivative using exponents. So I end up with y prime is equal to 4 sine x plus 12x to the 3/4. Now I'm going to take the antiderivative. Y is going to be equal to negative 4 cosine x. Now, this is where a lot of kids make a mistake. Most kids would say, oh, wait a second, the answer should be 4 cosine x. What they make the mistake of doing is saying, oh, the derivative of sine x is cosine x. But remember, we're not dealing with derivatives, we're dealing with antiderivatives. So you have to ask yourself, what function would produce a derivative of 4 sine x? It would have to be negative 4 cosine x, because the derivative of cosine x is negative sine x. So negative 4 cosine x would produce the derivative of 4 sine x. Then we add to that our value where we have an x raised now to the 7/4. We found that by taking our old exponent, 3/4, and adding 1 to it. Now I must take that 7/4 and divide it into my old coefficient, which was 12. 12 divided by 7/4 is the same as 12 multiplied by 4/7. So my new coefficient is 48 divided by 7. You multiply that by x to the 7/4, add c, and we state that c is an element of real numbers.